Given that IM equals to 0.1844144 and DM equals to 0.1802608, find M. Alright, here in this case, since both of the equations using the same M's, so we can use the principle of 1 plus IM over M to the power of 1, which is equals to 1 minus dm over m equals to -1. So we can represent this equation like this: 1 plus im to the power of m equals to 1 over 1 minus dm over m. So from here, our task is to make m as a subject. So after we have done all of these cross multiplication, here is the result. Therefore, to find m, we will get im times with the dm over im minus dm. And note that the values of im and dm are already given here. Therefore, we substitute all of the values. So 0.1844144 times with 0.1802608 over 0.1844144 minus 0.1802608. Therefore, we will get m equals to 8, which is the answer. So let's move on to the next question. An investment is made for 1 year in a fund whose accumulation function is a second-degree polynomial. The nominal rate of interest earned during the first half of the year is 5% convertible semi-annually. The effective rate of interest earned for the entire year is 7%. Find delta 0.5. Okay, firstly, note that the question said that the accumulation function is a second degree polynomial. So we can assume that the accumulation function is actually in quadratic form, which is this: it is square plus bt plus c, equal to 0. So we need to find the value of a, b, and c based on these statements. So firstly, we know that when we substitute a0, we will actually gonna get only c equal to 1. So for the second one, a 0.5, which is the first statement, during the first half of the year is 5% convertible semi-annually, we will get a 0.5 square plus b 0.5 plus c, which is equal to 1.025. And 1.025 is actually from the nominal formula, which is 1 plus 0.05 over 2, which is from the formula of the nominal rate of interest. Therefore, this is where it gets. Alright, so for A1, which is the effective rate of the interest earned for the entire year, which is actually equal to 1 year, we will get A1 equal to A1 square plus B1 plus C equal to 1.07, which is actually 1 plus I. Alright, so using these three equations to solve, and we will get, therefore we will get A equal to 0.04, B equal to 0.03, and C equals to 1. So when the question asks for delta, it means that we have to differentiate the whole equation. So we will get AT equals to 2AT plus B. So since the question asks for delta 0.5, we will get to A 0.04 T 0.5 plus B. B is actually 0.03. So we will get 0.07. And I forgot to remind you that delta is actually equal to differentiate of AT over AT. And since we are using 0.5 from the question above, the answer to the solution is actually 0.07 over 1.025, which is also equivalent to 14 over 205. In Fund X, money accumulates at a force of interest, given here delta the equation. In Fund Y, money accumulates at an annual effective interest rate of I. An amount of 1 is invested in each fund for 20 years. The value of Fund X at the end of 20 years is equal to the value of Fund Y at the end of 20 years. So calculate the value of Fund Y at the end of 1.5 years. So firstly, we need to find the accumulation value of Fund X first. So since the question already gave the equation to find the accumulation value of Fund X, so we need to integrate in terms of E. E integrate to the power of 20 to 0, since the range is 0 to 20, 0.01 t plus 0.1 we will get, thus we will get E4. So for Fund Y, since there is a statement said that the value of Fund X at the end of 20 years is equal to the value of Fund Y at the end of 20 years, so we can create an equation which is 1 plus I to the power of 20 equals to E to the power of 4. So from here, we can calculate directly the value of I. So therefore we will get I equal to 0.2214022758. Okay, refer back to the question. The question wants the value of Fund Y at the end of 1.5 years. So therefore, we need to calculate the AV 1.5 years for Y. So using the new I that we already get, we will have 1 plus 0.2214022758 to the power of 1.5, which is equivalent to 1.3498588808, or in terms of exponential we will get e to the power of 0.3. Method A assumes simple interest over final fraction periods, while method B assumes simple discount over final fraction periods. The annual effective rate of interest is 20%. Find the ratio of the present value of a payment to be made in 1.5 years computed under method A to that computed under method B. So firstly, using the given I, which is equal to 0.2, D is equal to I over 1 plus I, which is equivalent to 1 over 6. Okay, for method A, to find the present value, the formula is 1 plus I to the power of negative 1 times with 1 plus 1 over 2 times with 1 over 5 to the power of negative 1. For method B, since method B are using discount rate, so the formula is 1 plus I to the power of negative 1 also, times with 1 minus 1 over 2 times 1 over 6. Now, before we proceed, since the question wants final fraction periods here, so the question said that given 1.5 years, which is also equivalent to 1 full year, and half of it is actually the final fractional period. Therefore, the general formula is actually 1 plus I, which is t to the power of t. T is the full year, times with 1 minus interest, 1 minus discount, sorry, times with k. K is actually the final fractional period here, to the power of negative t. Now, before I proceed, let's look why I put 1 over 2 here and here. Alright, since the question given the final fraction periods, so the general formula that we need to use is this: 1 plus I to the power of t times with 1 plus I times k to the power of negative t, if the question asks for present value of I, let's say. So t and k here is actually here. 1.5 years is actually t equals to 1 year. T is 1 full year, while k is how much the final fractional periods for the given year. So therefore, that's why we use 1 over 2 times 1 over 5 here. Alright, so proceed to the question. The question asks for ratio. So ratio means method A over B. We will get, since both of them can be cancelled out, so we'll just include only 1 plus 1 over 2 times 1 over 5 to the power of negative 1 over 1 plus 1 over 2, 1 minus 1 over 2 times with 1 over 6 I 1. Therefore, when we calculate, we will get 120 over 120y by only using cross multiplication. In return for payments of $2,000 at the end of 4 years and $5,000 at the end of 10 years, an investor agreed to pay $3,000 immediately and to make an additional payment at the end of 3 years. Find the amount of additional payment if I4 equals to 0.06. Alright, in this case, we know that payment must be equal to how much we get. So therefore, we need to create a timeline first to understand the situation. So in returns of payment of 2,000 at the end of 4 years, which means at 4 years the investor will get $2,000. At the end of 10 years, he will get $5,000. And then the investor immediately wants to pay at T0 $3,000, and how much additional payment that must be made at the end of 3 years, which means at t equals to 3, there is an additional payment which we denote as x. So our equation, alright, so we need to choose a focal point to calculate the value of x. So therefore, I suggest that we use t equal to 0 as our focal point. So therefore, our equation will become 3,000 plus x times 1 plus 0.06 over 4, which is to the negative 3 times 4 equals to 2000. 1 plus 0.06 over 4, negative 4 times 4 plus 5000 times with 1 plus 0.06 over 4 to the power of negative 10 times 4. Okay. The reason is because since the question already gives the nominal rate of interest, so we need to use the nominal rate of interest formula to calculate the exact value. Therefore, we will get this expression for x, which is equal to 2000 times with all of this. Okay, before that, why we are using negative is because we bring the timeline forward. So when we bring the timeline forward, the power of the t will become negatives. Alright, so proceed to here. When doing the calculation, we will get the additional payment, which is $1,593. Find the amount to be paid at the end of 10 years, which is equivalent to 2 payments of $100 each. The first to be paid immediately and the second to be paid at the end of 5 years. Assume 5% of simple interest is earned from the date each payment is made, and use a comparison date of the end of 10 years for A, and for question B, the end of 15 years. So when doing this kind of question, like usual, we need to create a timeline diagram which represents the question itself. So therefore, for question A, since the date given is the end of 10 years, so at T0 it is $100. Why? Because it is said that it's to be paid immediately. And then at t equals to 5, which is also $100 here. Therefore, the payment to be paid at the end of 10 we denote as x. Alright. So, since we are looking for solution for x, so we are going to use x as the focal point of the equation. So therefore, our equation is going to be x equals to 100. Well, before that, our timeline will going to bring forward to x as we use x as the focal point itself. So 100, 1 plus 0.05, which is times with 5, plus 100 times with 1 plus 0.05 with times with 10. So the total of these two will become 125 plus 150, which is equivalent to $275. Alright. For question B, the method is almost the same as method A, but we will extend our timeline diagram to T15 here. So our diagram is going to be the same as above. When at T10 equals to x, 5 equals to 100, and also 0 equals to 100. Since in this case, since the question asks to use the focal point at T15, so our equation, will become x times with 1 plus 0.05 times 5, which is equivalent to 100, 1 plus 0.05 times 10 plus 100, 1 plus 0.05 times with 15. This is because we are using the same concept, which is moving the timeline forward. Okay, therefore, x will become 150 plus 175 over 1.25, which is also equivalent to $260. The present value of two payments of $100 each to be made at the end of n years and 2 years is $100. If I equals to 0.08, find n. Alright, so firstly, we need to create a timeline diagram which represents the question above. So we will get 100 at t0 and 100 at times n, and then another 100 payment at the end of 2n. Since the question asks for the present value, so our equation is going to be 100 v to the power of 2n plus 100 to the power v to the power of n equals to 100. So as you can see here, 2n and n is the form of quadratic. Therefore, we can solve this question using quadratic equation, which is when we rearrange, we will get 100v to the power of 2n plus 100v to the power of n minus 100 equals to 0. Alright, so v is actually, we are representing v as 1 plus I. Therefore, when we reduce this equation, we will get, by using calculator, we can calculate the value of v, which is 0.618033988. There is another value which we will get in a negative form, but we will reject the value as it is in negative form. Therefore, we will get v. Alright. Note that the question said that I equals to 0.08. So, it is actually, we can create an equation which leads to 1 plus 0.08, which is equal to 1 over v, because we know that I is actually equals to 1 over 1 minus d. Okay, so therefore 1.08 equals to 1 over 0.618033988. So we will get 1.08 to the power of n, which is equals to 1.618033991. So to solve n, we can, applying ln in both sides will become n ln 1.08 equals to ln 1.618033991. So move this ln to the right hand side, we will get ln 1.618033991 over ln 1.08. We'll get n equals to 6.25 years. One plus 0.915 to the power of 10 times 10. 1 plus 0.915 to the power of negative n plus 30. 1 plus 0.915 to the power of negative 2n equals to $67.5. Therefore, we will move the equation above so that it will become 10 times 1 plus 0.915 to the power of negative n plus 30 0.915 to the power of negative 2n equals to 67.5 over 1 plus 0.915 to the power of 10. Alright. Note that we can represent this equation in quadratic form. Therefore, we assume that x is equals to 1 plus 0.915 to the power of negative n. Therefore, our equation will become 30x squared plus 10x squared minus the whole thing in front, which is also equivalent to 28.12330,601, which is equivalent to 0. Therefore, using quadratic, we will obtain x equals to 0.81579 01067, sorry, or negative 1.149 and as usual we will reject the negative value. Okay, so when we look back at the top when we look back at the top, we let x is equal to 1.0195 to the power of negative n. Therefore, we can assume that 1.0915 to the power of negative n is equal to 0.8157901,067. So to find n in this case, we need to apply logarithm in both sides. So it will become negative n ln 1.0915 equals to ln 0.8157901,067. Therefore, to find n is actually equivalent to ln 0.8157901,067 over negative ln 1.0915. So we will get n equal to 2.33 years. A deposits 10 today and another 30 in 5 years into a fund, paying simple interest at 11% per year. B will make the same 2 deposits, but the 10 will be deposited at n years from today and 30 will be deposited to n years from today. So B's deposit earned an annual effective rate of 9.15%. At the end of 10 years, the accumulated value of B is equal to A. Find n. Therefore, first, as usual, we need to create a timeline diagram to represent the questions above. So we get here for Fund A is like this. At time 0, the payment is 10 ringgit. At time 5, the payment is 30 ringgit. At the end, since we didn't know the accumulation value until 10 years, so we will assume the value as x. So, given the information above, the first step is we need to find the accumulation value for Fund A, so that we can equalizing the value with Fund B. So first of all, for Fund A, accumulation on Fund A, which is x, is equal to 10 times 1 plus 0.11, and since the question said that A uses simple interest, therefore we are going to use simple interest formula, which is 0.11 times 10 plus 30 times 1 plus 0.11 to the power of 5. Therefore, we'll obtain 21 plus 46.5, which is equivalent to $67.50. Alright, so since the question said that the accumulated value of A is going to equal with B, after 10 years. So we can conclude that. So we need to create Fund B, formula of Fund B using the information above. So Fund B will become, so since the question said that Fund B using annual effective rate, therefore the formula is 10 times 1 plus 0.915, 10 to the power of 10 minus n, plus 31 plus 0.0915 to the power of 10 minus 2n equals to $67.5. Alright, so at this rate we can factorize above. Before I'm moving on to the next question, actually I'm apologizing that actually here is actually 0.0915, and also here 0.0915. Here is also 0.0915, and here is also 0.0915. Okay, here it's also gonna be 0.0915. Alright. Find an expression for the exact effective rate of interest at which payments of $300 at present, $200 at the end of 1 year, and $100 at the end of 2 years will accumulate to $700 at the end of 2 years. Alright, so firstly, we need to create a timeline which represents the question above. So, $300 at present, and $200 at the end of 1 year. 300. At the end of 1 year represents $200, and $100 at the end of 2 years will accumulate to $700, which is AV equal to $700. Alright, so to represent this timeline, we need to create an equation which leads to 300. So we are going to use T2 as focal point, which means that we will gonna bring the timeline forward. So from here to here, and from here to here. Right. So therefore, 300, 1 plus I, because we are using interest, effective rate of interest, times to the power of 2, plus 200, 1 plus I to the power of 1, plus 100 equals to $700. Alright, so if you noticed, the equation represents a quadratic form of it, So to make our calculation easier, we will let V equals to 1 plus I. Therefore, we will going to get the equation of 300 V square plus 200 V plus 100 equal to 700, or we can simplify that equal to 300 V square plus 200 V minus plus 600 equal to 0. So using factorization, we will get V is actually equal to 1.119632981, or negative 1.7862999648. Since we can reject already the value of negative here. Alright, so remember, we represented V as 1 plus I. Therefore, to find I, we need to minus 1. Therefore, I is equal to 0.11963291, or should I say 11.96%. the sum of the accumulated value of 1 at the end of 3 years at a certain effective rate of interest, I, and the present value of 1 to be paid at the end of 3 years at an effective rate of discount numerically equals to I, is 2.0096. Find the rate of I. Alright. So in this case, we need to create an equation which represents the question above. So, since we are dealing with both of the interest and also discount rate, so we can conclude that for accumulated value of interest, we will get 1 plus I to the power of 3. And for the present value for discount rate, we will get 1 minus D to the power of 3. Since the question said that both of the sum of these two is 2.0096, so we can create another equation, which is 1 plus I to the power of 3 plus 1 minus D to the power of 3 equals to 2.0096. And since the question said that discount numerically equals to I, therefore we can assume that it is actually equal to 1 plus I to the power of 3 plus 1 minus I to the power of 3 equals to 2.0096. So at this point, to solve this question, to find the value of I, we need to expand this equation. So the expansion will result in 1 plus 3I plus 3I square plus I square plus 1 minus 3I plus 3I square minus I square, which is equals to 2.0096. Therefore, we will open the brackets. So this is the equation, the full equation, which is 1 plus 3I plus 3I square plus I square plus 1 minus 3I plus 3I square minus I square. So we will look at the terms which we can be cancelled out, which is 3I minus 3I, and also I square against I square. So we are going to left with 6I square plus 2 equals to 2.0096. So we will move to the right hand side. We'll get 6I square equals to 0.0096, which results in 2 this minus 2. So I square will I square will become 0.0016, and therefore in finding I, we will square root of 0016, which results in I equals to 0.04 or 4%, which is the answer. The sum of 10,000 is invested for the months of July and August at 6% simple interest. Find the amount of interest earned: A, assuming exact simple interest; B, assuming ordinary simple interest; and C, assuming the banker's rule. Alright, so for the first question, A, by using the exact simple interest, which means we need to know how long the investment takes. So since the questions said the investment covers from July to August, it is actually from the 1st of July to the 1st of September. Alright, so we need to find, using the appendix A, we will get 1st July is equal to 182 days of the year, while 1st of September is actually equals to 246 days. So minus these two, we will get period of 246 minus 182, which is equivalent to 64 days. So to calculate the interest earned, 1,000, which is the present value, times with the interest given, 0.06, times with the period, which is 64 days, over 365, which is equivalent to 1 year. So when we calculate this, we will get, using calculator, $100.13. For B, Ordinary simple interest is the usage of the formula, which is denoted as y2 minus y1, times with 360 plus 30 m2 minus m1 plus d2 minus d1. Alright, what is the meaning of these three things? Y1 is actually the year of the first day of the investment, while Y2 is equal to the second date of the investment period. So therefore, the same goes to M and D, which is M represent months and D represent days. So in this case, since we are using from 1st July to 1st of since we are using from 1st July to the 1st of September, we will get 0, which is the same year, plus 30, 9 minus 7, plus, since both of them are using the same day, we will get here 0. Therefore, the total period will become 30 times 2, which is equivalent to 60 days. And the same will be applied to find the interest, which is 1000 times 0.06 times with 60 over 360 this time. This is the difference from the question A. So we will get, by using a calculator, which is equivalent to $100. For C, question C is gonna be the easiest among these three. By using the banker's rule, the period is actually equals to actual, which is from question A, over 360, which is equivalent to 64 days over 360. Therefore, we will apply this formula and we will get $106.67.